Good morning. My name is Bob Robbins, and these are two spectacular South American hair streak butterflies. I'll give you an idea of size. Maybe their wingspan 3, maybe 4 fingers wide. The one on the top, you see that red arrow? It points to a dark spot. This is a male secondary sexual structure. In other words, it's only found in males and it's used during courtship. The butterfly on the bottom is the male of a related species, but it doesn't have one. Simple question I'm going to ask today: why would one of these structures evolve, or why might it be lost? And the hypothesis from theory is pretty much common sense. These structures, like the scent pad, are postulated to promote species recognition, particularly in a female who's being courted by a male, so they contribute to reproductive isolation. If you're invading the range of a close relative, in that situation, you might evolve one. If you're already co-occurring sympatric with your closest relative, well, in that case, reproductive isolation is not an issue, and probably there wouldn't be a change. Finally, if you're allopatric, if you don't co-occur with your closest relative, in time you might well lose it, but once you lose it, you're going to remain allopatric unless you can regain it. So that's the hypothesis that we want to look at. The butterflies are the genus Arcus. This is what they look like in nature. They are truly spectacular. They occur primarily in wet forests from Mexico to southern Brazil. We revised the taxonomy. We now recognize 9 species. And here you're looking at the underside wing pattern of the males of those 9 species. Arcus is a very small genus, only 9 species, but we chose it because while it was evolving into 9 species, there was no evident evolution of the genitalia, male or female. There was no evident evolution of the male behavior, particularly territorial behavior, but there was conspicuous evolution of 2 of these male secondary sexual structures, and I'll show you them right now. The first is that scent pad. This is what the scent pad looks like in the 9 species of Arcus. On the bottom right, the variation to note, the bottom right, there's no scent pad. In the other 8, there is one, even though in one it's not so clear in the image. I mentioned this is a very complex structure. Normally, the upper and lower membranes of a butterfly wing are fused together except at the veins. Well, in a scent pad, if you look at a cross-section, the arrow on the left, there are columns keeping those membranes apart. The column on the right, there's an invagination, and histology tells us that there's a secretory cell in there, plus the base of an androconium. An androconium is a hollow scent-producing scale. These scent pads occur only in 2 tribes of hair-streaked butterflies that we believe are pretty closely related. The second structure we call a scent pouch. It's on the underside of the hind wing, and it's not nearly so conspicuous until you clear the wings. On the bottom left, you can see there's a pouch. Those black scales are androconia. The variation to note is that 6 species have a pouch with androconia. 2 species, like the one on the bottom right, have no pouch, no androconia, and 1 species has a pouch but no androconia. The scent pouches occur in 3 genera of hair-streaked butterflies that we believe are very closely related. How did they evolve? We inferred phylogenetic relationships among the species, and the ones, the red, blue, and black, represent 3 losses of either a scent pad or a scent pouch. There were no gains. If somebody wants to ask me about gains and losses afterwards, I'd love that question. To return to the hypothesis, as a result of those 3 losses of secondary sexual characters, we have 4 species that only have one of those two. And according to theory, we would expect that those would be allopatric, not co-occurring with their closest relatives. In 5 cases, there was no evolution of these structures. And in those cases, we might expect that they would be sympatric with their closest relatives. I apologize, numbers, but I think what you'll see here is that those with 2 kinds, 4 out of 5 of the species are sympatric with their closest relatives. For those which have only 1 kind, all 4 are allopatric, which agrees very strongly with theory. In the software Mesquite, we did randomization tests, and you would get a result so extreme in support of the theory only 1 to 2% of the time. We consider these results pretty significant, but next year we're going to expand the study quite a bit to more than 30 species. And I'd like to just thank my collaborators. Ananda was an undergraduate intern here a year and a half ago. Busby is an amateur who spends a lot of time in Ecuador. Marcelo was an undergraduate RTP intern here 16 years ago. He's now the curator of Lepidoptera at USP in Sao Paulo. Thank you. 6 minutes, wow. Questions? Yeah. The caterpillars feed on different plants? The question is, do the caterpillars feed on different plants? As far as we know, that basically one lineage feeds on Malvaceae, one feeds on Annonaceae, and for those who are botanists here, they are not very closely related at all.